Hello, I'm Rebecca Barnes and welcome to the Science at ESA podcast. The Hubble Space Telescope is one of the most successful astronomical space telescopes of all time. Its impact has been far-reaching and profound. Launched in 1990, the NASA ESA Hubble Space Telescope has provided astronomers with the deepest and clearest views of nearly all types of astronomical objects. Stunning Hubble images now provide a familiar view of the cosmos in visible, ultraviolet and near-infrared wavelengths. It is possible to view the visible universe from Earth. Hubble, however, has the vantage point of an orbit above the blurring turbulence of the Earth's upper atmosphere. Images from Hubble may indeed be beautiful, but these observations have also provided astronomers with key information about the universe.
In the last 10 or so years, more than 300 planets have been discovered orbiting stars other than the Sun. Hubble made the first measurement of the chemical makeup of the atmospheres of these exoplanets, detecting elements such as carbon, hydrogen, and oxygen in the atmosphere of a Jupiter-sized planet. After the Big Bang, the expansion of the universe started to slow down. However, when the universe was less than half its current age, it started to expand at an increasing rate. It was discovered that a mysterious repulsive force, known as dark energy, is the cause for this acceleration, working in opposition to gravity. The Hubble Space Telescope played a key role in this discovery by providing high-precision measurements of the brightness of ancient and therefore distant supernovae. This image is known as the Hubble Ultra Deep Field. It is the deepest view ever achieved of the visible ultraviolet and infrared universe. The image contains about 10,000 galaxies in an area of sky that is just 1/10 of the diameter of the full moon. Some of these galaxies are the oldest ever seen and existed just 400 million years after the Big Bang. Cepheid variables are a group of stars that change in brightness in a regular and therefore predictable way. This makes them extremely useful to measure vast distances in space. Hubble observations of Cepheid variables helped astronomers to determine the age of the universe. They found it to be between 13 and 14 billion years old, with an accuracy of about 10%. Cepheid variables are also used to determine the expansion rate of the universe.
The celebrated Hubble Space Telescope detects the visible light emitted from mature, fully formed stars and galaxies. To further investigate stars and galaxies of the early universe, astronomers need to study the ultraviolet and visible light emitted at this time. By the time this light reaches our solar system, it has been stretched or redshifted into infrared wavelengths during its vast journey across space and time. We're all familiar with the physical phenomenon known as the Doppler effect, which occurs when a source emitting sound or light waves is moving with respect to an observer. This is something that can clearly be heard when a siren or a fast train moves past. As the sound source moves towards us, the pitch gets higher, and then lower as the sound source moves away. Redshift is the astronomical version of the Doppler effect. In redshift, the peaks of electromagnetic waves are detected closer together as a source is moving towards us, which means that the light is shifted towards the blue portion of the spectrum. If a source is moving away from us, the wave peaks are more stretched out, and hence the light is shifted towards the red portion of the electromagnetic spectrum. In the 1920s, Edwin Hubble discovered that the velocity of a galaxy moving away from us is directly proportional to its distance. This is known as Hubble's law. The faintest, most distant galaxies are moving away from us with a greater velocity, and therefore exhibit a larger redshift. Most galaxies have been observed to be moving away from us. However, redshift is not due to the waves themselves stretching, it is due to the expansion of the universe. Electromagnetic waves are carried on the fabric of space, and because this is expanding, the waves appear to be stretched. Redshifts are measured from the signature absorption and emission lines of atoms and molecules that are present in the spectrum of celestial objects. The wavelengths of these signature lines can be measured very accurately and are known. They can therefore be compared to the spectrum of a galaxy to calculate the redshift. If signature absorption and emission lines of a galaxy's spectrum have shifted to wavelengths that are twice as long, the galaxy has a redshift of 1. If the signature lines have shifted to wavelengths that are 3 times as long, the galaxy has a redshift of 2. The Hubble Deep Field Survey exposed faint and distant galaxies with redshifts up to about 6. To view galaxies at even higher redshifts, in other words, to go back to the earliest galaxies, then astronomers need a telescope that is extremely sensitive at near and mid-infrared wavelengths. In the tradition of the Hubble Space Telescope, astronomers will use its successor, the James Webb Space Telescope, to follow the redshift back to the earliest stars and galaxies. By constantly pushing technology to its limit, they are sure to achieve their goals. I'm Rebecca Barnes. Thank you for watching the Science at ESA vodcast.